Right guys, I've got another question in which I have to find the derivative, and you can see that there is an exponent over the thing which I have to calculate the derivative for. So what can I do? I can simply put it equal to y, and then I can add an increment in both of my variables, and then I can move this y towards the right hand side of the equation so that it combines up with the second term, and there is x plus delta x, and I can simply put the value of y which I just supposed in the first function. I didn't actually suppose, I just made it equal to y so that it becomes a function. Okay, so I told you how you can find the derivative of a term with an exponent using the binomial expression method, right? So we are going to use the binomial expression method in this video, and you have to watch it carefully. So I told you that the term which is present on the rightmost side of your right hand side, this is the term which is present on the rightmost side of your right hand side, okay, and that is x3 by 2. So let me just take it out common. Now if you see in the first term, what is present in the first term? X 3 by 2, so that becomes common 1, okay, and delta x we are going to deal it later. X 3 by 2 is present over here, so I can take out common, and that is actually equal to 1, okay, that's fine, that's good. Now you can see that there is a delta x over here, so first of all I will write a plus sign, and then delta x actually is not common in this term, right? So what can I write? Delta x divided by x, okay, and that should make sense because if I multiplied this term which I have taken out common again into all of these terms, what would happen? It would give me x 3 by 2 plus delta x x x, okay, everything is having 3 by 2, so I can simply put a power over the bracket, okay, so there is 3 by 2 minus 1 goes as it is. No, actually I'm being multiplied, yeah, that's good. And there is our x, right? We multiplied the x inside the term, okay, so what would happen? This would cancel, and what is remaining? X plus delta x 3 by 2 minus x 3 by 2, right? So this is the same term which I started dealing with, okay, this was the same term, right? So you can see that if I multiplied the term which I took out common, and I'm getting the same answer, so it means that I'm on the right path, okay. Hope that makes sense. If you simply look at a simple term, forget about all these things, you simply look at this thing, 2x plus 4x cube, what would happen? What is common over here? It is actually 2x that is common, so I'm going to take out 2x common. What would remain? 1, right, plus 4 divided by 2 2, right, then x square, because only one power is being taken out common, so x 3 by 2 3, and there is in the denominator x, so this x would go up, x3 dot x1 with a negative sign, and when the bases are same, the powers are added, x3 minus 1 gives x power 2, so this is remaining over here, okay, and I took out common. Now if you multiply this 2x inside, what would happen? 2x plus 2 to the 4 x square x cube. This is the same term which I was given in the first step. I hope that you understood what I was trying to say, and now let's just apply the binomial theorem, or I should say expression, or yep, binomial series. So this goes the first bracket, and now 1 becomes as it is, power multiplied by the second term plus power and subtracted from 1 and 2 factorial, and power the second term is being squared, okay, dot 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 minus 1, okay. If you like, you can put another bracket over here which resembles that this term is being multiplied by the term present over here, okay, but that's all right. You can simply cancel 1 from everything, and x 3 by 2, and we got 3 by 2 delta x divided by x, okay, plus 3 by 2, okay, 3 by 2 minus 1 divided by 2 factorial, and just for your knowledge, 2 factorial is actually equal to 2, okay, so don't worry about it, and delta x squared divided by x squared plus dot dot dot, okay. Now I have to take out delta x common, right? So this is the delta x and this is the delta x. I am going to take out delta x common. Oops, sorry, I forgot to write it. 3 divided by 2 x, okay, delta x is just removed from this equation. 3 by 2 then 3 by 2 minus 1 2 factorial, and there is our delta x square. Okay, and if I take out one delta x common, what would happen? Delta x remains. Okay, so delta x divided by x square plus dot dot dot. And if there's delta x common, you can simply move towards the fifth step of differentiation using the first principle, and that is dividing the delta x on both sides. And the sixth step actually says that you have to apply the limit over this entire thing which you are dealing with. Okay, so we have x3 by 2, then 3 divided by 2x plus 3 by 2 and 3 by 2 minus 1 divided by 2 factorial, and then delta x divided by x square plus dot dot dot. Wherever there's a delta x present inside this thing, whatever it is over here, you can put a 0 over there. So there is only one delta x present, and that is over here. So if I put 0 over here, everything present over here is being multiplied, and this entire terms become 0. I can simply remove it, and x3 by 2 plus multiplied by 3 by 2x, this is our derivative for the function